introduce yourself and then you can start.
Yeah, thank you, sir. Thank you. Thank you, sir. Yes. Hello, friends. Good morning. Myself, Prashant Patil, and my colleague, Madhuri Tita ma'am. We are both our physics teacher teaching in Kirti M. Dungarsi College, Dadar West, Mumbai, which is run under Deccan Education Society. Actually, today I'm very happy. Even in such pandemic situation, COVID-19 situation, we try to teach, we try to learn by using such online setup. So I'm really thanks Maharashtra government and SART.
शासनामध्ये नागरिकांना अधिकार मिळतात आणि जेव्हा नागरिकांना अधिकार मिळतात याचाच अर्थ तिथे लोकशाही शासन व्यवस्था आहे. बघा, लोकशाही है ना, शब्दच सांगतो बघा, लोकांचं राज्य. करेक्ट. म्हणजे जिथे लोक आपल्या प्रतिनिधींना निवडून देतात आणि त्यानुसार राज्य चालवलं जातं, शासन चालवलं जातं. ठीक आहे. मग अशा लोकशाही शासन व्यवस्थेचे दोन प्रकार आहेत पूर्ण जगभरात. संसदीय लोकशाही शासन आणि अध्यक्षीय लोकशाही शासन. संसदीय लोकशाही शासन भारतामध्ये दिसेल, जर्मनी जपानमध्ये दिसेल, युनायटेड किंगडम मध्ये दिसेल, आणि अध्यक्षीय लोकशाही शासन तुम्हाला अमेरिकेत दिसेल, ब्राझील, साऊथ आफ्रिका म्हणजे दक्षिण आफ्रिकेत दिसेल. ठीक आहे. म्हणजे असे काही देश आहेत की ज्यांच्या काही देश अध्यक्षीय शासन पद्धती राबवतात, काही देश संसदीय शासन पद्धती राबवतात. आता आपल्याला बघायचंय संसदीय शासन पद्धती म्हणजे नक्की काय, म्हणजे हा फरक कशावरून आला संसदीय आणि अध्यक्षीय. तर हा फरक निव्वळ कायदेमंडळ आणि कार्यकारी मंडळ यातील संबंधानुसार केला जातो. आता ते काय ते आपण आता बघूया. ठीक आहे. सो पार्लमेंटरी सिस्टम अँड द प्रेसिडेन्शियल सिस्टम. This division can be made, or you can classify the democratic system as parliamentary system and presidential system on the basis of the relationship between legislature and executive. Now, legislature, that means the body which makes the law, and executive, the body or the person who executes the law. Correct. So the democratic government, or you say presidential or parliamentary government, whatever the kind of the nature of relationship between executive and legislature, decide what kind of parliamentary or presidential system will be there. Correct. So in parliamentary system, we'll first look at
scalar. We are thinking about at here only magnitude. We are not think about a direction. We are not think about a direction. We are think only about at here magnitude. हम यहाँ पे सिर्फ magnitude के बारे में सोचेंगे, ना तो हम यहाँ पे direction के बारे में सोचेंगे, ना तो any other quantity के बारे में हम सोचेंगे. We are think only at here about magnitude. हम यहाँ पे magnitude के बारे में सोचेंगे. Okay, ठीक है. Go ahead. तो अगर मुझे magnitude के बारे में सोचना है, तो I would like to take some example. Okay, if you take a metal rod and if you want to measure its length is a physical quantity. So whenever we want to show the length of metal rod, then we can tell that 2 meters. So 2 meters is sufficient information about length. Here 2 is a number, and meter is nothing but a standard unit. So if we see carefully that 2 meters is sufficient information to describe
a nominal executive is the head of the state. If we look at India, okay, our president is the head of the state. And if we look at United Kingdom, because we are comparing, no, this section is the comparative government and politics. We are comparing our political system with United Kingdom and USA. So in United Kingdom, you will find there is a monarch. Okay, on the screen you must be seeing their photos. Ramnath Kovind ji is there. He is the president of India. And Elizabeth II is there. She is the monarch of United Kingdom. So these both persons are the head of the state in their specific nations. Correct? So in India, if anybody asks you, who is the head of the state in India? President of India is the head of the state in India. Who is the head of the state in United Kingdom? Monarch is the head of the state in the United Kingdom. Correct? But they are nominal. Nominal, that means they are for the namesake. They are for the signatory purpose. The final orders are signed under by their names. So they are, the word itself says nominal, for the namesake. Okay, for signatory purpose. They do not actually exercise the power. Whenever they want to exercise power, they have to take the advice of the Prime Minister and the Council of Ministers. Correct? So, even though certain discretionary powers have been given to them, but nominal powers, most in the Constitution, and in the Constitution it is written. Then we have to look at the classification of the parliamentary system. So there are two groups, we can say, or two types: Republic parliamentary system and the constitutional monarchy parliamentary system. Where Republic is India, I have given you on the screen, you must be seeing the Indian flag is there. That means India follows the Republic system, and United Kingdom system, United Kingdom follows the constitutional monarchy system. Now you will ask me, Miss, what do you mean by Republic and the constitutional monarchy? So Republic, that means the head of the state is elected by the public, though indirectly. So our president, as the head of the state, is elected by people or the people's representatives. Correct? But in constitutional monarchy, it is on the heredity base. So hereditary post is there in United Kingdom. Therefore, it is called as constitutional monarchy. Okay, whereas in India we have republic system, where republic, that means when the head of the state is elected by the public. Correct? So in India we have president as the head of the state, and in UK, where we have constitutional monarchy, having monarch as the head of the state. Clear? Then we have to move towards real executive. Real executive, that means the person, the executive, having power and actually exercising the power. Correct? So in India, we have Prime Minister, and the Council of Ministers are the head of the government. Prime Minister is the leader of the Council of Ministers, and therefore he is the head of the government. Whereas in United Kingdom, same way, Prime Minister and his cabinet, they are the head of the government. Now, who appoints them? Obviously, President appoints the Prime Minister of India. President of India appoints the Prime Minister of India, and Monarch of United Kingdom appoints the Prime Minister of United Kingdom. So this person, Boris Johnson, he has been invited. I'll give you the current knowledge, that because you are now
vector, where we think magnitude as well as direction. Okay, now then go ahead. Is there is nothing but a velocity. Okay, just हमने example देखा था speed का 90 km/h. Okay, it's only magnitude. But अगर आप मुंबई से लेके पुणे जा रहे हो, so this is the direction. 90 km/h is magnitude, and Mumbai to Pune is a direction. So that time there is nothing but the magnitude as well as direction. So that is a velocity. Okay, life में वेलोसिटी होनी चाहिए, स्पीड तो होना ही चाहिए, नो डाउट, बट उसको एक प्रॉपर डायरेक्शन होना चाहिए. आपने 10th में बहुत स्टडी किया 90%, 12th में भी आपको 90%, 95% चाहिए, बट उसको एक प्रॉपर डायरेक्शन होनी चाहिए. विदाउट डायरेक्शन, ओके, आप समझ गए होंगे. सो वेलोसिटी, so there is nothing but the magnitude and as well as direction. So in such manner there is a linear momentum. Linear momentum is also vector quantity, which we can explain by magnitude as well as direction. Acceleration, force, yeah, force is also important. Door अगर मुझे open करना है या close करना है, so it is necessary we're applying force in which direction, that is also most important. Impulse, pressure, This is all quantities are vector quantity, which we can completely describe by using magnitude and as well as direction. Okay, so here vectors, if you think about magnitude and direction, so there is important factor is also direction. So this vector we cannot add or subtract by using simple rule of algebra. So vector we can be added or subtracted by using vector algebra, that is vector law of addition. We are used at a vector law of addition. Those quantity obey vector law of addition, that is also called vector, that is called vector. Okay, if you take example of electric current, चलो मान लो हम यहाँ पे example लेते हैं electric current के बारे में. Electric current having magnitude as well as direction. Suppose this is electric current I1. I1 is nothing but 2 ampere. Okay, look at here. Current, electric current. Suppose this is I1. I1 is nothing but 2 ampere. Come at this junction. Suppose this is one junction. And at the same junction, there is also another current is coming. This is nothing but the I2. I2 is nothing but the at here 2 ampere. Okay, I2 is also at here 2 ampere. Okay, and if suppose there is a I, this is the I, which are leaving from this junction. So that time this I is nothing but the at here 4 ampere. This is the 4 ampere. If you see carefully, there is a magnitude is added. This is Kirchhoff law of junction, which we are learning in 12th standard, no doubt. So if you see carefully, here I1 is 2 ampere, look at their direction. I2 is 2 ampere, look at their direction. Both the direction is opposite. If both the direction is opposite, then obviously, अगर मैं वेक्टर्स के बारे में सोच रहा होता तो कैंसिल हो जाता. सो दैट टाइम I is equal to nothing but this 0 ampere. But नहीं. What happened at here? ये 2 ampere and 2 ampere is nothing but the 4 ampere. Means there is only simple addition. Means electric current is not obey vector algebra or vector law of addition. यहाँ पे जो भी इलेक्ट्रिक करंट है वो इलेक्ट्रिक करंट वेक्टर अलजेब्रा या तो वेक्टर्स लॉ ऑफ एडिशन फॉलो नहीं करता है. अगर वो फॉलो नहीं करेगा तो सो इट इज नॉट अ वेक्टर. सो हियर current is not, electric current is not a vector, even its magnitude and direction. So what I want to say? I want to say here, those quantity having direction and magnitude, they are all are not vectors. If they obey, if they follow vector algebra, if they follow vector law of addition, then and then we can call to them vector. Okay, got it? What I'm saying?
पद्धती आहे. ओके, आणि हे तुम्हाला आता थोड्या वेळाने लक्षात येईल की कसं ठरलं जातं. हा, तर सुरुवातीला आपण बघूया संसदीय शासन पद्धती. त्याच्यामध्ये की देशाचा जो प्रमुख आहे, हा राज्याचा किंवा देशाचा प्रमुख हा एक विशिष्ट व्यक्ती असतो आणि शासनाचा प्रमुख हा एक विशिष्ट व्यक्ती असतो. म्हणजे 2 प्रकारच्या व्यक्ती असतात. येते लक्षात? इथे एकच व्यक्ती नाहीये जो शासनाचा पण प्रमुख आहे आणि देशाचा पण प्रमुख आहे. नाही, संसदीय शासन पद्धतीमध्ये देशाचा किंवा संविधानाने सांगितल्याप्रमाणे राज्याचा प्रमुख हा राष्ट्रपती असतो भारताचा विचार केला तर, आणि पंतप्रधान आणि त्याचं मंत्रिमंडळ हा शासनाचा प्रमुख असतो. ठीक आहे. आणि जर युनायटेड किंगडमचा विचार केला तर मोनार्क, तुम्हाला स्क्रीनवर दिसत असेल एलिझाबेथ 2 है ना, त्या राणीचा फोटो आहे आणि ती मोनार्क आहे तिथे. तर तिथे म्हणजे राजाला महत्व आहे, कारण तिथे रॉयल फॅमिलीला पहिल्यापासूनच महत्व दिलं जातं. त्यांच्याकडे अधिकार होते पहिल्यापासूनच, आणि नंतर तिथे लोकशाही आली आणि मग थोडीशी शासन व्यवस्था बदलली. ठीक आहे. त्यामुळे तिथे सुद्धा देशाचा प्रमुख हा मोनार्क असतो आणि आपल्या भारतामध्ये देशाचा प्रमुख हा राष्ट्रपती असतो. म्हणजेच आपला राष्ट्रपती हा लोकांच्या प्रतिनिधींनी निवडून दिलेला असतो, म्हणून आपल्याकडे गणराज्य आहे. कारण आपल्याकडे जनता, जनतेचा राजा म्हणजे जनतेने निवडून दिलेला प्रतिनिधी म्हणजे राष्ट्रपती, आणि तो देशाचा प्रमुख. आणि युनायटेड किंगडम मध्ये बघायला गेलं तर त्यांच्याकडे संविधानात्मक राजेशाही आहे, आणि म्हणजे तिथे राजाला महत्व आहे आणि त्यांचा राजा हा एका विशिष्ट कुटुंबातून आलेला असतो. त्यामुळे अनुवंशिक पद्धत ही तुम्हाला युनायटेड किंगडम मध्ये दिसते, आणि आपल्याकडे मात्र जनतेने निवडून दिलेला गणराज्य पद्धत आहे. आलं लक्षात? नंतर आपण बघायचंय की वास्तविक कार्य हे तर नाममात्र आहेत दोघही. जरी राज्याचे देशाचे प्रमुख असले तरी ते नाममात्र असतात, केवळ नावापुरते, त्यांच्या नावाने देश चालतो एवढ्यापुरते. पण खरे सत्ता चालवणारे कोण असतात, खरे सत्ताधारी कोण आहेत, तर त्यांना शासन प्रमुख म्हटलं जातं. आणि ते वास्तविक कार्यकारी प्रमुख ते म्हणजे आपल्या देशामध्ये पंतप्रधान आणि मंत्रिमंडळ, आणि युनायटेड किंगडम मध्ये सुद्धा पंतप्रधान आणि त्यांचं मंत्रिमंडळ. पण त्यांच्या नेमणुका कोण करतात? औपचारिक रीतीने आपल्या पंतप्रधान आणि मंत्रिमंडळाची नेमणूक राष्ट्रपती करतात. म्हणजे मंत्रिमंडळाची नेमणूक करताना सुद्धा पहिले पंतप्रधान मंत्र्यांना निवडतात आणि मग त्यांची नेमणूक राष्ट्रपती करतात. मोनार्क म्हणजे युनायटेड किंगडम मध्ये सुद्धा पंतप्रधान आणि मंत्रिमंडळाची नेमणूक औपचारिकपणे राजा करतात किंवा राणी करते. ठीक आहे. पण ते निवडून दिलेले असतात. जे खरे शासनाचे प्रमुख आहेत, जे खरोखर सत्ता चालवतात, त्यांना जनता निवडून देते. आणि मग जेव्हा त्यांना बहुमत मिळतं तेव्हा मग बहुमत सिद्ध करून ते नेता होतात आणि मग त्यांना पंतप्रधान पद आणि मग मंत्रीपद मिळतं. कळतंय? आणि मग ह्यांना कुठे बहुमत सिद्ध करावं लागतं? कायदे मंडळात. आणि म्हणून म्हणजे बघा, जे खरोखर सत्ता चालवतात ते कायदे मंडळाशी संबंधित असतात, कायदे मंडळाचे सभासद असतात. आणि म्हणून आपल्याकडे म्हटलं जातं की आपल्याकडे संसदीय शासन पद्धती आहे, कारण आपल्याकडे कायदे मंडळाला संसद म्हटलं जातं. ठीक आहे.
Direction. So whenever we want to show at your vector, so there is nothing but the magnitude and direction is required. So directed line segment, जो भी directed line segment होगी और by an arrow, जिसे हम आगे arrow देने वाले हैं, उसे हम कहेंगे vector. The length of line segment drawn to scale gives its magnitude and arrow shows its direction. Okay, if you take example at here about displacement. Okay, if you take example displacement of a body which move from P to Q, so you can represent in such manner, move from P to Q. So here P is nothing but the starting point. Here P is nothing but the starting point, which is nothing but the tail of that vector. If you see carefully, this P is the starting point of the displacement, which is nothing but the tail of the vector, and Q is nothing but the ending of the vector, which is nothing but the head of vector. जहां से स्टार्ट होता है वो टेल होता है वेक्टर का, एंड जहां पे एंड होता है वो हेड होता है वेक्टर का. So here displacement of body from P to Q can be represented where the starting point P is called tail and the end point Q is called at here arrowhead of the vector, means P to Q. And we can show at here, we can write at here symbolically is PQ, and above there is an arrow. So this is what we call vector PQ. If you want to go from Mumbai to Pune, so Mumbai is the starting point, Pune is the ending point. So this is the direction shows Mumbai to Pune. So that we can write it as symbolically MP, vector MP. Okay, so we are used at a two word. We are used at a two alphabet. We can also show at a one single capital letter, which is arrow above it. जिसके ऊपर हम arrow देंगे. Example, vector A. Vector we can also show by using this single capital letter. Just like vector A, just like vector X. If you see carefully toward this vector X, here X is nothing but its magnitude and the above arrow shows its direction. Here this X is nothing but its magnitude. And this above arrow, it shows direction of that vector. Okay, this is shown by symbolically and this is shown by graphically. Vector can be represented by directed line segment or by an arrow. Its length is nothing but the magnitude and the arrow is nothing but the shows the direction. This vector we can also write in single capital letter. If you take example of vector X, where X is nothing but its magnitude and above arrow shows its direction. Okay, this is the representation of vector, how we can represent the vector. Now here, we wanted to learn different types of vectors. Okay, there's different types of vectors. We study at here one by one. We like to study at here its definition. So first, vector is nothing but the zero vector, null vector. Yeah, zero vector, which is also called null vector. What is zero vector? A vector having zero magnitude. Yeah, it's zero magnitude, but yes, it's having particular direction. That vector is nothing but they call it a zero vector. A vector having zero magnitude with a particular direction, that is nothing but they call it a zero vector. And symbolically, we can represent it by vector zero. This is zero vector. Its magnitude is zero, and above arrow shows its direction. Okay, we'll take example. If you take example at here, velocity vector of a stationary particle is a zero vector. What is this is? I would like to tell you, don't worry. Stationary particle, stationary means constant. Okay, मैं एक ऐसा पार्टिकल लेता हूं जो स्टेशनरी है, एक ही जगह पे है. There is no displacement. There is no displacement. So that time obviously its velocity is zero. Why? Velocity is defined as the rate of change of displacement. What is velocity? The rate of change of displacement. But there is no displacement. Why? Because it is stationary. If there is no displacement, that time its velocity is zero. And hence here, velocity vector of a stationary particle is a zero vector. Okay, I will also take example, second example. Here, second example is nothing but the acceleration vector of an object moving with uniform velocity is a zero vector. Okay, I will like to explain it, don't worry. Acceleration, what is acceleration? The rate of change of velocity with respect to time. The rate of change of velocity with respect to time. But there is no change of velocity. Why? Because velocity is uniform. If that velocity is uniform, there is no change in velocity. Is that time acceleration is zero. The acceleration vector of an object moving with uniform velocity means there is no change in velocity. Its velocity is uniform. There is no change in velocity. Means its acceleration is zero. Clear? I would like to take also second example. I think you know this might is about simple pendulum. मेरे ख्याल से आपको पता होगा या तो clock pendulum. If you take example of this clock pendulum, okay, if clock pendulum oscillates one oscillation, if suppose this clock pendulum completed its one oscillation, it's from extreme position to mean position and then mean position to right extreme position, and if it's once again comes to its original position, suppose this one is not over here, and once again if it's returned to its original position, so how many displacement there? The displacement is zero. That is null vector or zero vector. The displacement of one oscillation is zero vector. I'm saying, if you take example of this clock pendulum, if you take example of clock pendulum, so there is a displacement is zero. वहां पे displacement क्या हो जाएगा बच्चों? Zero हो जाएगा. So there is displacement is zero of one oscillation. This is zero vector or null vector. Okay, go ahead. Then we'll study at here about equal vector. Equal vector? Yes, नाम से ही बहुत कुछ पता चल जाता है. देखते हैं. If suppose I take two vectors. अगर मैंने यहाँ पे दो vectors लिए. Okay, A and B, and both vector having same magnitude and same direction. चलो मान लो मैंने यहाँ पे दो वेक्टर्स लिए A and B, and these both vector having same magnitude and same direction. Okay, but most important condition is that here these two vector A and vector B having same physical quantity. If suppose vector A is the velocity vector, if vector B is a velocity vector, and if its magnitude and direction are same, then we can tell both are equal vector. Okay, if you take example at here vector A, and if I take at here example of vector B, here the magnitude and direction of these both vector are same, then we can tell at here these both vector are equal vector. What is equal vectors? Two vectors A and B representing the same physical quantity are said to be equal if and only if they have the same magnitude and direction. Magnitude and direction same hona chahiye. Then we study at here about negative vector, which is also called opposite vector. So what is negative vector? What is opposite vector? Look at here. Suppose I'm taken at a two vector, vector P and vector Q. Both having magnitude is same. But suppose if you just take at a vector q which are exact in opposite direction of vector p, यहाँ पे जो वेक्टर q है उसका मैग्नीट्यूड एंड द मैग्नीट्यूड ऑफ वेक्टर p both are same but the direction of vector q is opposite of that vector p, then this vector q is nothing but the else called negative vector of vector p. या तो vector p is a negative vector of vector q. So what is a negative vector? A negative vector of a given vector is a vector of the same magnitude but opposite in direction to that of given vector. चलो मान लो आपको यहाँ पे दिया है vector p and we are taking at a vector q. It's both having same magnitude but the direction of vector q is opposite to that of vector p. So that time this vector p is a negative vector of vector q, or vector q is a negative vector of vector p. Okay, this is about that negative vector. Okay, then we will like to go ahead toward resultant vector. Yes, it is result, no doubt. It is a result. Suppose I'm taking at a first vector which having magnitude is 5 centimeter. It is a displacement vector. चलो मैंने यहाँ पे वेक्टर a लिया जिसका डिस्प्लेसमेंट है 5 सेंटीमीटर. Now I'm taking at another vector, vector b, which is also displacement vector. Its magnitude is 2 centimeter. And if we add to them, then what do we get? Then its resultant vector is nothing but the 5 centimeter plus 2 centimeter is nothing but the 7 centimeter. This is the resultant vector, which is the result of this two vector. This resultant vector is nothing but the result of this vector. Actually, the resultant vector is a single vector. कि जो भी resultant vector होता है वो single vector होता है, which produce same effect as produced by all other vectors together, which produce by all the vectors together. यहाँ पे vector a and vector b ने जो effect produce किया है उसका जो result है वो एक single vector है, and that single vector is called at your resultant vector, which is the result of this vectors. The resultant of two or more vectors is a single vector which produces the same effect, as produced by all the vectors together. That is called resultant vector. Resultant vector is a single vector. Okay, we like to go ahead. The next definition is a position vector. Yes, position vector. What is position vector? It shows position of a particle. Position vector shows position of a particle with respect to origin of the coordinate system. Okay, चलो मान लो आप क्लास में बैठे हो, okay, और टीचर आपको पढ़ा रहे. अगर आपके पेरेंट्स का कॉल आता है, चलो मान लो अद्वैत है और अद्वैत क्लासरूम में बैठा है और अद्वैत के पेरेंट्स ने मुझे कॉल किया, टीचर को कॉल किया और पूछा क्या अद्वैत क्लास में प्रेजेंट है, तो मैं बताऊंगा कि यस अद्वैत क्लास में प्रेजेंट है, वो अभी सेकंड बेंच पे बैठा हुआ है. So I'm shows position of that Advait student from its me means teacher. So in such manner we can take at a number of student and we can show its position by using these vectors. So that time origin is nothing but the teacher and there is student is nothing but the particles. Okay, so what is position vector? A vector which gives the position of particle. A vector which gives the position of particle at a point with respect to origin of a coordinate system. Position vector gives the position of particle with respect to origin of a coordinate system. That vector is nothing but the call at here position vector. Okay, then I would like to study at here. About unit vector. अभी हमें यहाँ पे स्टडी करना है यूनिट वेक्टर के बारे में. What is unit vector? A vector having unit magnitude. Unit means 1. हम एक ऐसा वेक्टर लेना चाहते हैं जिसका मैग्नीट्यूड 1 होगा, बट इट्स हैविंग डायरेक्शन. और उसकी डायरेक्शन कौन सी होगी? जो हमें वेक्टर दिया है उसके डायरेक्शन की अकॉर्डिंग. दैट वेक्टर इज नथिंग बट वी कॉल इट यूनिट वेक्टर. सो व्हाट इज यूनिट वेक्टर? A vector having unit magnitude means one magnitude in a given direction is called unit vector. This unit vector having direction. Okay, if we take vector A, okay, we want to find out its magnitude. The magnitude of we want to find out its unit vector. Okay, take it here, magnitude of vector A. Magnitude of vector A is A And there is a direction of vector A is given by this u cap. U cap is nothing but the unit vector. Okay, so we can write that your vector A is equal to its magnitude A into u cap. U cap is nothing but the unit vector. Okay, let's see carefully at here. Suppose I'm taking at here one vector. This is nothing but the vector A, and this vector A is nothing but the 5 centimeter और 3 सेंटीमीटर. चलो मान लो ये वेक्टर A है और जो displacement vector है, it is nothing but the 3 centimeter. So we can take at here 3 parts. This is nothing but the 1, this is nothing but the 2, and this is nothing but the 3. Okay, so this is the unit vector. This is unit vector, and this unit vector having direction. अब यहाँ पे जो vector है इस unit vector की direction होगी. उसकी direction कौन सी होगी? जो vector A की direction है. So this is u cap, this is unit vector. And if you see carefully, this unit vector having unit magnitude. This unit vector having unit magnitude. इस unit vector का magnitude 1 है, unit है. But इस unit vector को direction है. कौन सी direction है? जो vector A की direction है. So what is unit vector? A vector having unit magnitude in a given direction. That is nothing but we call it here unit vector. उसे हम क्या कहेंगे? Unit vector कहेंगे. तो हम unit vector क्यों लेंगे? Why we take unit vector? ये unit vector we can take at here because using that unit vector we can take separate magnitude and its direction. हम जो भी वेक्टर है उस वेक्टर को उसके मैग्नीट्यूड एंड उसके डायरेक्शन में सेपरेट कर सकते हैं, स्पेसिफिक हम उसको डिस्क्राइब कर सकते हैं. तो अगर मुझे कोई भी वेक्टर लेना है, अगर मैं उसका यूनिट वेक्टर के साथ लेता हूं तो मैं मैग्नीट्यूड एंड उस यूनिट वेक्टर को साथ में लेके उस वेक्टर को रिप्रेजेंट कर सकता हूं. दिस यूनिट वेक्टर हैविंग मैग्नीट्यूड इज 1, so there is no change in the magnitude of that vector. So here using unit vector we can write magnitude and its direction. Okay, we can also write u cap. U cap is equal to vector A upon A. It means अगर कोई भी वेक्टर को उसके मैग्नीट्यूड से अगर मैंने डिवाइड किया तो आंसर 1 तो आना ही है, यूनिट आना ही है, एंड इट्स हैविंग आल्सो डायरेक्शन. सो दैट इज नथिंग बट द कॉल इट u cap और यूनिट वेक्टर. ओके, कोई भी वेक्टर को उसके ही मैग्नीट्यूड से अगर हमने डिवाइड किया तो हमें यूनिट वेक्टर मिलता है. Just like vector 1 is equal to vector 5 centimeter upon 5 centimeter. So there is nothing but the answer is 1 and u cap. So this is nothing but the unit vector. A vector having unit magnitude. Okay. Now here we take 3 axes, Cartesian coordinate system. X-axis, Y-axis and Z-axis. Okay. There is a rectangular component. Along X-axis we take unit vector is I. Along y-axis, we take unit vector is j, and along z-axis, we take unit vector is k. Okay, if we think about x-axis, so we can write that your vector x is equal to unit vector I into x in such manner. This is vector A. Just हमने यहाँ पे लिखा है vector A is equal to A into u cap. In the same manner, we can write that here vector x is equal to unit vector I into x. So we can also write that here unit vector I is equal to vector x upon x. In same manner, we can write it here about vector y. Vector y is equal to unit vector j into y. Okay, so unit vector j is equal to vector y upon y. Okay, along z-axis we use unit vector k. So vector z is equal to unit vector k into z. So we can write that unit vector k is equal to vector z upon z. It means अगर कोई भी वेक्टर को उसके मैग्नीट्यूड से अगर हमने डिवाइड किया तो हमें उसका यूनिट वेक्टर मिलता है. ओके, या तो अगर हमने कोई वेक्टर को उसके मैग्नीट्यूड के साथ यूनिट वेक्टर से मल्टीप्लाई किया तो हमें उस वेक्टर का मैग्नीट्यूड एंड एज वेल एज डायरेक्शन मिलता है. सो अलोंग एक्स एक्सिस दैट इज यूनिट वेक्टर इज I, along y axis that is unit vector is j, and along z axis that is unit vector is k. Always remember, if you see carefully my dears, here we study definition. We are study at a scalar, then हमने study किया vector, and then हमने study किया definitions. Why we study about this vector analysis? हम ये क्यों study करना चाहते हैं? Why we study this vector analysis? Actually, this vector analysis is widely used in structural engineering. Yes, structural engineering. Because we know that there is, if you take a building, so there is a force acting in downward direction. So there is a support is required in such manner which balance to that force. There is a different type of structure, bridges, buildings. This is architecture. This is structural engineering. So their support is required in such manner which are capable to handle this all forces. There is wind force on these buildings. There's different types of forces on this building. So it's technique, it's structural technique, structural engineering, where we use this vector analysis. Okay, so now we study at here about operation of vectors. We are thinking about operation, means we can add or subtract of that vector. But when we add or subtract to that vector, that is most important concept. The vectors of same type, I say same type. If first vector is force, then second vector is also force required. So the vectors of same type we can add or subtract by using vector law of algebra, by vector law of addition. How we are saying study at you one by one. Okay, if the vectors are in same direction. Okay, if you take vectors, if you take two vectors and both vectors having same direction, means they are parallel to each other. Then they are added. तो हम उसको add कर सकते हैं just like this. Suppose we are taking a vector A and vector B, both having same direction. Vector A having 5 magnitude, vector B having 3 magnitude. Then the resultant vector is nothing but the magnitude is 8 centimeter. And look at their direction. The direction of resultant vector is the same as the direction of vector A and vector B. If the two vectors is in same direction, means both are parallel, then we can add to them. But suppose if their vectors are in opposite direction, then means they are opposite, is they are anti-parallel, then what happens? Okay, suppose I'm taking at a vector A having magnitude is 5 centimeter and look at their direction. And then another vector is vector B having magnitude is 3 centimeter, look at their direction. Now then their resultant vectors, if you see carefully, my dears, vector A having magnitude is 5 centimeter, vector B having magnitude is 3 centimeter, but their direction are opposite, they are anti-parallel, then we can subtract. Then there is a subtraction. Large magnitude में से small magnitude minus होगा and जो result हमें मिलेगा उस resultant vector की direction same होगी जो vector large है उसके according. So vector A, look at their direction. And its magnitude is large by 2 centimeter than vector B. So the direction of the resultant vector is the same as the direction of large magnitude vector. Okay, so here we study about addition and subtraction, but when they are parallel or anti-parallel. But sometimes there is a vectors which are not parallel or anti-parallel, then can we add to them? Can we subtract to them? Yes, we can add or subtract by using law of triangle of addition. What I'm saying, my dears? यहाँ पे जो वेक्टर्स पैरेलल है या तो एंटी पैरेलल है तो हमने उसको ऐड किया, हमने उसको सब्सट्रैक्ट किया. बट हो सकता है कि ये दो वेक्टर्स ना तो एक दूसरे को पैरेलल हो ना तो एंटी पैरेलल हो, तो कैन वी ऐड और सब्सट्रैक्ट टू देम? Yes, we can add or subtract to them by using triangle law of addition. So what is triangle law of vector addition? We must study at here. And my dears, this law is very important for us. How we like to study at here. Okay, suppose I'm taking at it two vector A and vector B. Okay, this is two vectors. And these two vectors represented by its magnitude and direction. Look at here, vector A. Its magnitude is A, above arrow shows its direction. Here, vector B. B is nothing but its magnitude and above arrow shows its direction. So here these two vectors. Okay, now these two vectors having same type means suppose vector A is a force vector, vector B is a force vector, both vectors require same type and both vectors represented by magnitude and direction. And suppose if you take these two vectors are two sides of the triangle taken in order. तो मैंने यहाँ पे ये दो वेक्टर्स लिए हैं, दिस वेक्टर A and वेक्टर B, and we are taken in order, means जहाँ पे फर्स्ट वेक्टर खत्म होता है वहाँ पे सेकंड वेक्टर स्टार्ट होता है. Okay, head of the first vector there is a starting of tail of the second vector. Okay, so when we taken in order, so this is the two side of the triangle, this is the two side of the triangle, then the resultant vector, obviously resultant vector having magnitude as well as direction. तो यहाँ पे मैं वेक्टर सी को रिजल्टेंट वेक्टर लेता हूँ जिसका मैग्नीट्यूड है एंड एज वेल एज डायरेक्शन भी है, and which is nothing but the third side of the triangle. If you see carefully toward this vector A and vector B, these are the two vectors and they are taken in order. But this is incomplete triangle. Okay, when we take at a third side, then triangle is complete. But here this third side is nothing but the resultant vector, and this resultant vector having magnitude and as well as direction. And this resultant vector start from the starting point of the first vector and end at the ending point of the second vector. Look at this resultant vector. If you see carefully toward this resultant vector is start from the starting point of the first vector and end at the ending point of the second vector. Means in opposite sense. I say opposite sense. Why I'm saying opposite sense? Look at here. चलो मान लो मैंने यहाँ पे वेक्टर A लिया. Okay, ठीक है. And this is nothing but the vector B है. Okay, ठीक है. This is vector A. Okay. This is nothing but the vector B. ये आपका vector B है. And if suppose I'm taken at a vector C in such manner, अगर चलो मान लो मैं vector C अगर इस तरीके से ले लेता तो, so that time they are in same sense. उस same sense में चला जाता, मतलब जहाँ पे first खत्म होता वहाँ पे second start होता और जहाँ पे second खत्म होता वहाँ पे third start हो जाता. So they are in same sense. But हमें यहाँ पे same sense नहीं लेना है तो हमें वहाँ पे opposite sense लेना है. मतलब हमें कैसा लेना है यहाँ पे? तो हमें लेना है यहाँ पे vector C is in opposite sense, means start from the starting point of the first vector and end at the ending point of the second vector. And this is the resultant vector, which is nothing but the vector A plus vector B. Okay, I'm taken at here two vector, vector A and vector B. Okay, I'm taken at here two vector, vector A and vector B, and both are in same, both are taken two sides of the triangle, taken in order. Then the resultant vector, which is the third side of the triangle, drawn in the opposite sense. It means starting from the point of the first vector and end at the ending point of second vector. So this is the addition of vectors. Look at that. Look at there. I kindly request to all of you, my dear students, look at their statement also. Statement is also important for us because statement having more value. Okay, look at this statement. So what is statement there? If two vectors describing the same physical quantity, there are two vectors describing two same physical quantity, represented magnitude and direction. Look at here, vector A and vector B. Both are same type and represented by magnitude and direction. And these two vectors are taken two sides of the triangle, taken in order. जहाँ पे first vector खत्म होता है, वहाँ पे second vector start होता है, taken in order, and which are the two sides of the triangle. So then the resultant vector represented by magnitude and direction, which is the third side of the triangle. Third side of the triangle, drawn in opposite sense, means start from the starting point of the first vector and end point of the ending point of second vector. So this is triangle law for vector addition. So this is triangle law for vector addition. यहाँ पे हमने addition किया. अगर दो vectors, if you take these two vectors, and these two vectors are not parallel or anti-parallel, even though we can add to them by using vector law of addition. Can we subtract to them? Can we subtract to them by using vector law of addition? Yes, we can also subtract to them by using vector law of addition. How? कैसे? जरा देखते हैं. चलो मान लो I'm taken at this vector A. This is nothing but the vector A. Okay, this is vector A. Okay, now I'm taken vector B but in opposite direction. Okay, look at here this vector B. There is vector B को आप देख लो. Look at that direction. Now I'm taken at a vector B but in opposite direction. If you take at a vector B in opposite direction, then it is nothing but the minus vector B. I think you know this about negative vector. I think you know about negative vector. What is negative vector? Their magnitude is same, but its direction is opposite. So this is minus vector B. Okay, now this is the two side of this triangle. Then the resultant vector is nothing but the vector R. This is the resultant vector, which is nothing but the vector R. And this resultant vector R, is nothing but the vector A minus vector B. Vector A minus vector B, and this is nothing but the resultant vector. So if you see carefully, there is vector A and vector B subtracted by using this triangle of vector addition. So if you see in well manner, we can add or subtract by using triangle of vector addition. मैंने क्या किया यहाँ पे addition subtraction करते समय we take vector A and then we take vector B, but here this vector B we are taking opposite direction, so it is minus vector B. So that time the resultant vector R is nothing but the vector A minus vector B. Okay, this is nothing but the about subtraction. So triangle of vector addition we can also use for addition and we can also use for subtraction also. Okay, तो हमने यहाँ पे addition देख लिया है, हमने यहाँ पे अभी subtraction देखा है. This is nothing but the addition. Addition करते समय कैसे किया है? Taken in order, and the resultant vector is nothing but the sum of these two vectors. Okay, now this triangle law we are use for showing vector addition is commutative. ये triangle law हम use करेंगे किस लिए यूज करेंगे? टू शो करने के लिए. क्या शो करना है हमें? वेक्टर एडिशन इज कम्यूटेटिव, ये शो करने के लिए. ओके, व्हाट इज कम्यूटेटिव? If we take at two vectors, vector p and vector q, so we can write at a vector p plus vector q. If it's commutative, then we can write at a vector q plus vector p. Okay, how? कैसे? जरा हम केयरफुली देख लेते हैं. चलो हम यहाँ पे दो वेक्टर्स लेते हैं, वेक्टर a एंड वेक्टर b. सॉरी, यहाँ पे हम दो वेक्टर्स लेते हैं, वेक्टर p एंड वेक्टर q. Okay, OA vector p and here AB is nothing but the vector q taken in order. उनको हमने order में लिया, तो obviously it's having resultant vector. Okay, OA is nothing but the vector p and AB is nothing but the vector q, and we have taken in order. हमने उसको order में लिया, then we get at a resultant vector, vector R, which is nothing but the third vector of this triangle, which is the resultant of this vector, which is starting from the starting point of the first vector, and this resultant vector end at the ending point of second vector. This is the resultant vector. It means if you see carefully, vector p plus vector q is nothing but the vector R. Am I right? Am I right? If you see carefully toward this triangle OAB, so that time there is nothing but the vector p plus vector q is nothing but the vector R, which is nothing but the vector OB. Okay. Now, I would like to take another triangle. Which one another triangle? I will take at a triangle OCB. What I'm taking right now, I'm taking triangle OCB. Okay, there is first vector is vector q, second vector is vector p, taken in order. हमने उसको order में लिया, पहले vector q लिया, then हमने vector p लिया, taken in order. So that time the resultant vector is nothing but the third vector, which is nothing but the vector R, which is starting from the starting point of this first vector, and this resultant vector end at the ending point of second vector. So if you see carefully, that time vector OC plus vector CB is nothing but the vector OB. So you can write at a vector Q plus vector P is nothing but the vector R. Okay, now look at here equation 1 and 2. So if you see carefully that equation 1 and 2, so it is nothing but the vector P plus vector Q is nothing but the vector R, which is vector OB. Now the triangle OCB, there is nothing but the vector q plus vector p is nothing but the vector R, which is vector OB. Their left side are same, their right side are same, then obviously their left side are also same. So we can write that a vector p plus vector q is nothing but the vector q plus vector p. Means this vector addition is commutative. Got it? So this is vector addition is commutative. Now we want right now study at vector addition is associative. अभी हमें यहाँ पे vector addition is associative study करना है. We take three vectors, vector A, vector B, and vector C. So we can write at a in bracket vector A plus vector B, and outside of the bracket there is plus vector C, which is equal to vector A plus in bracket vector B plus vector C. Okay, कैसे? जरा उसके भी बारे में हम सोच लेते हैं. That is associative. But how we can prove they are associative? Look at that. I'm taking at a three vectors. Okay, हम यहाँ पे three vectors लेंगे. बट ये थ्री वेक्टर्स लेने से पहले मैं जरा कुछ बताना चाहता हूँ. जरा केयरफुली देख लो बच्चों, आप यहाँ पे हमें क्या स्टडी करना है. चलो मान लो मैं यहाँ पे सबसे पहले लेता हूँ O, देन P, दिस इज O, दिस इज वेक्टर A. चलो मान लो ये वेक्टर A है, देन आई एम टेकन एट ओके. चलो मान लो पहले यहाँ पे वेक्टर A है आपका, दिस इज वेक्टर A. ओके, ठीक है, दिस इज वेक्टर B. सो द रिजल्टेंट वेक्टर इज so that resultant vector is nothing but this one. Am I right? This is resultant vector. This is vector A. ये आपका vector A है. This is nothing but the vector A, this is vector B है, and this is nothing but the vector C. Okay, ठीक है. This is vector A, this is vector B, and this is nothing but the आपका resultant vector. So this is resultant vector is nothing but the vector A plus vector B. So this is vector A plus vector B. Am I right? Okay. Vector A plus vector B. This one is nothing but the. चलो ये vector A plus vector B हो. Okay. Now please everyone see carefully triangle OQR. Now look at the triangle OQR. अब जरा ट्रायंगल OQR की तरफ देखिए. Look at the triangle OQR. OQR. अगर मैं ट्रायंगल OQR लेता हूं तो if you take at a triangle OQR, so that time this OQ is nothing but the vector A plus vector B. This is the first side. This is the second side, which is vector C. This is first side.
Somebody made time.
Yeah, 2 minutes, ma'am, only. Then this article is completed. So this is vector A plus B, and this is vector C. So this is the resultant vector R, which is the third side. This is the third side. Okay. So this is vector R. So vector R is equal to vector A plus vector B in bracket plus vector C. So we get at a resultant vector R. So from triangle OQR. In the same manner, we can take at here triangle OPR. Look at that triangle OPR. What I'm taken triangle OPR. Look at that OPR. आपको क्या पता चलेगा OPR से? जरा शांत माइंड से देख लो OPR. अगर आप OPR की तरफ देखेंगे तो हमें क्या पता चलता है? This is nothing but the OPR. Okay. This is nothing but the first vector, vector A. This is the second vector, which is the vector B plus vector C. Okay, ये vector B plus vector C कहाँ से आएगा? Triangle PQR से. This is vector B, this is vector C, and the addition of these two is nothing but the vector B plus vector C. So that vector A plus vector B plus vector C is nothing but the resultant vector R. So if you see carefully toward this triangle OQR, the resultant vector is vector R is nothing but the vector A plus vector B, and the third vector is vector C. And the triangle OPR is nothing but the vector A plus vector B plus vector C is nothing but the vector R. So if you see carefully, their left side are same, then obviously the right side is also same. So we can write it here vector in bracket vector A plus vector B bracket complete plus vector C is equal to vector A plus vector B plus vector C. And hence this vector addition is associative. And in such manner their vector addition is associative. इस तरह से यहाँ पे वेक्टर एडिशन क्या है? एसोसिएटिव है. Got it, my dears? So this is nothing but the this is nothing but the about vector addition is associative. Okay. So in next lecture we try to study at here about law parallelogram vector, which are very, very important article for us, because on this article there is one practical is also depend. There is some numericals also depend on this law parallelogram vectors. Okay. So today we learn, आज हमने क्या स्टडी किया? आज हमने स्टडी किया फर्स्ट स्केलर. व्हाट इज स्केलर? मैग्नीट्यूड. देन हमने स्टडी किया वेक्टर, which can be completely described by magnitude and direction. Then हमने स्टडी किया distinguish between scalar and vector points. There is a difference. How we can represent to that vector by using graphical. Then next हमने स्टडी किया zero vector, which is zero magnitude but particular direction. Then equal vector, same magnitude and direction. Then हमने स्टडी किया negative vector, magnitude same but direction opposite. Then हमने स्टडी किया resultant vector, which is the result of two or more vectors. Then हमने स्टडी किया position vector, which shows position of the particle with respect to origin. Then हमने स्टडी किया unit vector, a vector having unit magnitude but its particular direction. Its magnitude is 1 but it's having direction. Along x-axis unit vector is I, along y-axis unit vector is j, and along z-axis there is unit vector is k. Then हमने यहाँ पे addition and subtraction लिया. If the both are same direction, parallel, then we can add. If they are in opposite direction, then we can subtract. But if suppose they are not parallel or anti-parallel, then we can add to them by using triangle law of vector addition, or we can subtract. This triangle law we are used for shows vector addition is commutative, and also we are shows vector addition is associative. So my dears, today we'll like to stop at here. But before stop this lecture, I would like to tell to all of you, we'll meet tomorrow and we will like to take at your next articles. So I request you, come on time and please present. And second gentle reminder to all of you, please use SMS, means social distance, mask, and wash your hand continuously, sanitizer, and be safe, my dears. So I'd like to stop my lectures. Thank you, my dears. Thank you. Sir, Abhinav, sir? Yeah.
Yes, sir.
Yeah, I would like to stop now.
Thanks. Thank you very much, sir.
Thank you, sir. Thank you.